Hello, everyone, and thank you for joining us on today's Senza Fili Sparring Partners webinar, How Will RIC Make Open RAN More Efficient? Our speakers today are Simona Marinova, Solution Architect at Bell Canada, and Monica Paolini, Principal at Senza Fili. I'm Kendra Chamberlain, and I will be moderating our webinar. In Sparring Partners debates, we watch our speakers discuss a topic live on video. We would like to encourage our audience to participate in the conversation, so please share your comments and questions using the chat and Q&A functions on the Zoom taskbar. All comments are visible to all participants, so please keep the conversation polite and respectful. And our speakers will do their best to address questions as they go along and as they become relevant to the topics being discussed, so no need to hold your questions. With that, I'll hand it over to Monica.
Kendra, thank you so much for the introduction, and welcome all of you in the audience, and Simona as my sparring partner today. What we're going to talk about today is RIC, not to be confused with RISC, which was the last sparring partners, and I sometimes get confused because the similarity of the names. It's RIC and Open RAN. And I have to say that RIC has quickly risen to prominence. I would say that it's the the hottest topic on Open RAN these days. So initially, Open RAN was defined as having open fronthaul interface. Now it's becoming increasingly clear that that's step number one, but then eventually we need to have RIC as well. So we will talk about all of that, what it is, why is it important, and how we're going to do it. And so that's a great topic. I'm currently working on a report on Open RAN, and this is going to be a major topic in the report. So let's talk to Simona, who has been doing a lot of work on this. Simona, can you tell the audience who you are, what you do, and why you care about RIC?
Thank you, Monica, and thank you for the invitation. I'm very happy to be here. I'm currently holding a solution architect role within Bell Canada, and within my role, I'm doing a lot of technology discovery, so R&D type of work within very interesting fields such as ORAN, especially on the RIC side of things, then network slicing, and more recently, network slice assurance, and different topics in which we can harness the power of ML and AI to make networks more efficient.
Very good. So why don't we get started? I think that most people would know what RIC is, but why don't we get started and say what really is and why do we need it?
Sure. Great opening question. So I would say, going back to the basically the foundational blocks of ORAN, right? There's three main ones that we always kind of revert to. One is the openness and the new interfaces that are being introduced. The other one is fully softwarized networks implemented on white box generic hardware. And then the third one is, once you have all these two, then you can implement, use intelligence and implement more optimized ways to control the network for whichever objective you have in mind. So then ORAN introduces two RAN intelligent controllers, or RICs. They operate in different time frames, right? We have the near real-time RIC, which operates within sub-second up to a second type of time frame. And then we have the non-real-time RIC, which operates in a time frame that is more than a second, so it could be minutes or hours even, so long-term compared to the near real-time RIC. And when we think about the RICs, I always like to say it's the control layer for sure, but it's almost like, if implemented correctly, it's almost like an abstraction layer between the RAN nodes, so your radio access network, and then any application that brings more intelligence, a better decision-making, data-driven decision-making into the network. So the promise of RICs then becomes we are better able to harness the power of the openness, softwarization, and intelligence to bring better first visibility into how the RAN performs, and then be able to use that data that we have to improve the performance of the network and get to those applications that are driving us for intelligence, such as vehicle to everything or industry 5.0 types of applications.
So in the current networks, so, okay, let's put it the other way. In an open RAN environment, you do need to have this kind of management of the network outside of the single vendor, because you might not have a single vendor, you typically don't. So you need to manage it sort of, let's say, from the outside. So currently, what the kind of functionality that the RIC introduces is being done within the single vendor framework, correct? So this is why we need RIC, because you need to pull everything together and manage it. So it's not just that having different parts of the RAN interoperating, is to basically to interoperate well and manage
yeah. So
yeah.
That's a great point. So it's exactly like that. So we would like to have almost like a common control layer for any type of RAN vendor, right? So we would have any RAN vendor, the big ones, smaller RAN vendors, and we would be able to manage and control all of them from a single point of view or of control plane and management.
Now let's move the other direction. Is that once we have a RIC going, once everything works well, is there anything that is going to stop an operator that has a RAN that is not open RAN, just a regular RAN, traditional RAN, from using RIC? And why would they? Would they do it? What would be the advantage of doing that?
So I think long term, if we think in the years to come, it will be the operators' will to kind of have the RICs control all the RAN, right? And the RAN is an evolution. It's not, we can't really just separate by, let's say, sort of legacy RAN versus open RAN. There's flavors in between, right? We have virtualized RAN or vRAN. We have Cloud RAN or C-RAN. We have different flavors in between. So I think moving forward into the future, it will be the best approach to simplify how we do the management and orchestration of all the resources across the board for any RAN type that we have. However, I think we need a lot of work to be done prior to having the opportunity to use the RICs to control, manage, orchestrate all the resources for the RAN.
No, absolutely, and I think that this is really important, and this is something that you know, we the two of us have been talking about, and I also been talking in terms of thinking of open RAN instead of using capital O to have the non-capitalized open RAN, which is really exactly what you say. Is that there are different flavors. There is different ways to open the RAN. And so the RIC might come in different ways and different shapes, which is, I guess, the whole idea of openness brings you flexibility. And so you can use different parts. Now, I see that there is a question, and I would like to take it because actually it's a good question. Is if it's the real-time RIC. Well, so first of all, I'm going to have to file a complaint about not to you, Simona, but in general to the industry, that we have the near time and the non-real time, which have the same acronym. It's just like capitalized differently, and it just doesn't seem like the best way to go to make it user-friendly. However, let's just take that apart. So we have non-real time and near real time and non-real time. Do we have a real-time RIC, and shouldn't we have one?
So that's a good question. I would say so far, if we look into the efforts to standardize, right, from the ORAN Alliance, there's no work group right now that's real-time RIC. However, there have been, conversations amongst, industry leaders in academia about the importance of real time, and whether it be real time applications or real time RIC as well. So I would say, I think moving forward, and this is my belief, there will be a real time RIC. However, at this point in time, there is no such one coming from standards. Now, there has been interesting research work. So this would be academic work and implementation in research testbeds that shows an implementation of either a real-time RIC or applications that are running in real time. So much more time stringent than the 1 second of the near real-time RIC. So there has been research work, and we're yet to see more serious work in terms of standardization of such RIC.
Now, let me ask a follow-up question on this, because so if you go to non-real time, near, and real time, it's sort of like, again, there are different flavors of Open RAN. So is it like, does it make sense to have 3 parts of it rather than have a general RIC that would accommodate apps that are more or less in real time? I mean, what do we need to have 2 or 3 of them?
That's a very good question. So I think it comes back to a little bit on the objectives of the RICs, and then in terms of practicality of deployment. So when I say objectives, is both near real-time RIC and non-real-time RIC are collecting specific data from specific interfaces, and then usually they, based on the time urgency of the control loops for the specific objectives, they can be separated, right? So you could have forecasting, use a traffic forecasting application that doesn't really need to run in near real time. You're looking at longer trends and trying to predict more long-term how the network behaves. And on the other hand, you could have very near real-time applications that go back to, for example, RAN slice assurance for next generation applications like V2X or Industry 5.0, right? So the time frame is very different. And then, of course, we also have the practicality of deploying the RICs in production, right? When we are looking into deploying the RICs, we need to make sure that we understand the best way to deploy, meaning from a more centralized point of view or decentralized, how are we actually going to do that? So for instance, in terms of deployment, there is usually one non-real-time RIC that talks to multiple near real-time RICs that then talk to multiple different, many actually E2 nodes or RAN nodes, right? So the almost to some extent hierarchical approach works, I believe, much better when we're talking about scalability of deployment, which is not actually something that we have tackled too much these days, because I think we're still a little bit behind working on different other aspects of the RICs. So
I was thinking that you'd have one RIC, say a non-real time RIC, and then all the xApps and all the apps would just go onto that one. But you're talking about RICs. So does it mean that every operator would have multiple RICs in their network at the same time?
Yes. So from the point of view of non-real time and near real time, right? Mm-hmm. There is you definitely need both of those RICs in the network moving forward, right? Mm-hmm. And the architecture of how you deploy those RICs in the operator production network is a little bit different. I would say, and the scalability is different. For instance, there is architecture proposed in the work groups within the ORAN Alliance, in which you could have potentially the non-real-time RIC together, located with DSMO, the service management and orchestration, or you can have them separate. But you could have that sort of architecture, which right now I think it's a little bit more tightly integrated due to other functionalities that these two major parts of the management and orchestration share. But then the near real-time RIC, it really needs to be closer to the RAN nodes, right? Because if we are to say we need 1 second decision making, we need to account for everything that happens within that second. For example, how data is exported from the RAN nodes, then how the data processing and management is done within the near real-time RIC, and then the application, the xApp in the near real-time RIC that takes that data and has some decision making, some inference being done, and then control back if we need to make some change to the RAN nodes. So within that second, we also have to account for for example, the network time in between, right? So if we're further away, if there's a bigger distance between the RAN nodes that we're controlling with the near real-time RIC, we're introducing some other delays as well. So, long term, we need to account for that as well.
Very helpful, because this was not clear to me. Now, it's a follow-up question of examples of research work on real-time RIC. Can you give us some example about what we needed?
I'm sorry, could you repeat that?
If we have any example of research work on real-time RIC.
Yes, there is an example. I've come across so far 2 research papers. One is on real-time RIC, and the other one is on real-time applications called xApps. I can share later with you and the audience the references for those 2 papers.
Perfect. Okay, we'll get to that. We also have some other questions, and we're gonna get them in a second. But since we're talking about real time and non-real time, I'm sorry, near and non, is there an issue of interoperability? Because we have the whole issue about interoperability between CU and DU. So, and that is something that we've been talking a lot. But when it comes to the RIC, don't we have the same issue? And in fact, it's even worse, because you need to have different RICs interoperating. They need to interoperate with DU and CU with the RAN. And then they also have to be working with the apps. And the apps need to work with the so doesn't it in a way get worse? The whole interoperability issue is just kind of like this combinatorial explosion of that. I don't want to make it not even worse.
Combinatorial explosion.
But you know what I mean? It's like, isn't that a real issue here?
I believe it is, and I think we have to be a little bit cognizant of the fact that, and really, ORAN by default is a paradigm shift in the way that we've previously built RAN networks, the way we've operated RAN networks, right? So it's as the standards progress and as more and more interoperability tests and performance tests are being done, we see, bettering of the interoperability problem. But I would say it does the interoperability challenge. It does pose some, I would say, delays in the way that we built the ORAN networks, including or excluding the RICs, and the way we then, test for performance, test to different applications and build different applications on top of that. So there's many different interfaces in ORAN in general with the disaggregation, and then there's the interfaces that connect the RICs to the RAN nodes. So E2, for example, would be the interface that connects the near real-time RIC to the RAN nodes. And then we have O1 that connects to the SMO and non-RT RIC. Then we have O2, and then we have A1, which is the interface between the near real-time RIC and non-real-time RIC, and a few others. So there's a lot of work that's being done in terms of standardizing these interfaces and it's an ongoing work, right? ORAN is still not a very mature technology. It's still standardization-wise and implementation-wise, it's still ongoing. So there's plenty to be done in terms of the interface description from the standards perspective, and then the implementation of the standards by the majority of or all of the vendors in the space, right? That would require some time.
Okay, let's get to that, and then we're gonna get to your questions in the audience very soon. But let's not slip away the standardization issue. So the standardization issue is the standardization for the front haul is the ORAN Alliance. What about the RIC? Is it going to be all the standardization ORAN Alliance?
So within the ORAN Alliance, there is at this point, I believe, 11 work groups, and right now 4 focus groups and many other research groups. And within the work groups, there's work groups that look very much into the RIC. So for example, work group 2 within the ORAN Alliance is working on the standardization of different aspects for the non-RT RIC. So from the architecture to the interfaces and everything in between, that's the responsibility of work group 2. Now we have work group 3 that is working on the standardization and of the architecture and interfaces of the near real-time RIC. And then we have work groups that work almost in conjunction together, I would say, on certain aspects about the RICs, but not too much into the architecture and the interfaces. And those are, for example, work group 1 that defines all the use cases around ORAN. So when we talk about traffic steering or energy efficiency, I know that you've been very active in that space, or RAN slice assurance, any type of applications, the description of those applications comes from work group 1. Then we have work group 6 that works on the cloudification aspects of the ORAN framework, and then many others. But so I would say within the work groups, maybe almost half of those work groups are either directly working on the architecture and interfaces or influencing that work with the work that they're performing. So there's a lot of movement, there's a lot of activity, but as usual, we can always do better.
What about 3GPP? Is that getting involved at all in well, actually Open RAN in general and RIC?
So 3GPP is a huge body, and generally speaking, that's where all the standardization of wireless technology comes from. There's definitely connections within ORAN and 3GPP, and some overlaps that are all constantly being worked through. But 3GPP is here to stay, and some of the 3GPP specifications, like for instance, how we collect and what types of data we collect from the RAN nodes, right? The specifications for that, which is very, very meaningful from a perspective of using ORAN and the data we collect for different use cases. Those come from 3GPP. And, same goes to other sort of standardization bodies. ORAN rapporteurs, ORAN folks do share a lot of the standardization, and with different groups, ETSI being one of those as well. Then we have new and emerging technologies and open source projects such as Nefio, for example, that will to some extent influence or potentially influence the development of some of the aspects within ORAN as a whole. So there's always conversations ongoing. All standards bodies need to interact in concert, right? To be able to build really interoperable networks and be really clear about the standards that come from everywhere. So it's not an easy task.
No. But then again, okay. So standardization, that's kind of like the foundation of everything, right? But then you need to make sure that those standards are actually implemented and you have interoperability. So you need to have some certification or some way to test interoperability. And then you need to make sure that actually interoperability not only means that the different parts work together, but they also work together well, which is, so you can have interoperability, but yet not the kind of performance that you'd expect. What is the path? So once we get the standardization done, what's next?
Very good question. So I think how the industry has approached this so far, it would be mostly looking to partner with specific vendors and spend a little bit of time on the interoperability to make sure that the vendors, and if we're looking at the full ORAN stack, right, then you have a very difficult job, because you need to align vendors for all the different components. So that would be RU, DU, CU. It would be the underlying CAS platform, or OCloud, as the ORAN terminology suggests. And then we have the near real-time RIC, non-real-time RIC, SMO, right? So it hasn't been very easy to find a almost like a more sustainable way of bringing vendors together and creating that environment in which we can easily test first the interoperability of all of these different components, and then, as you said, test the performance. Because when we look at it from an operator perspective, right, one of the things that we need to make sure is that it's not that, you know, we have an ORAN implementation or deployment that provides a fully interoperable stack, but we must make sure that we do offer the same or better level of performance than with traditional RAN, right? We need to get to that point of increased testing and realization. So I would also mention that, and this is a little bit newer to me as I'm just becoming a member, but within TIP, there's a subgroup called RIA, and RIA has been doing some great work in terms of providing blueprints for different use cases. And the use case, as we were saying, it could be energy efficiency, or it could be traffic steering, it could be, you know, slice assurance. It could be any of the use cases that are defined within work group 1 and also prioritized by operators. And then after those blueprints are created, vendors of different domains within ORAN are put together to test certain, you know, test the interoperability, and then have some test cases. So then after that, if everything is according to what the blueprint suggests it should be, then they're awarded badges. And other than that, there is the third aspect I would mention is OTICs, right? So within ORAN, some of the focus groups are really focusing on creating the research environments, the R&D environments to test really in a neutral environment as the interoperability and the performance of different stacks. And OTICs and those plugfests have been really meaningful in terms of you know, bringing a little bit more understanding into how these ORAN deployments actually perform.
And I guess that, you know, as the ecosystem opens, all this collaboration becomes much more important than they were in the past. Not that it didn't exist in the past, but now becomes really central to the success of the whole enterprise. And I think that the whole badge system that TIP is introducing is quite interesting, because it's sort of, you know, I guess we still think that something is either it is interoperable or it is not. It is working or it is not, like a binary thing. But with the badge system, you kind of introduce the concept that two components can be interoperable for some purposes, but not for others. And that's okay, because they're not necessarily trying to do everything. And that's the whole beauty of having the flexibility and being able to mix. But then you need to know, as an operator, what is that you can mix and what is that you cannot mix. So and maybe you can explain the whole badge concept, because I think it's a really powerful one in terms of, and especially it's helpful in helping us progressing through interoperability and thinking about interoperability in a new way. Is that?
It is, yeah, and I would say it's even to me it's a new concept, I have to admit. I was lucky to be introduced to TIPRIA just recently, and just starting to realize the not just the benefits in terms of the badges, but just the amount of knowledge, the level of understanding that you can achieve, the level of discovery of how the technology actually performs by creating those blueprints and by putting different vendors together to basically showcase the capabilities. And as more and more of vendors, and when I talk about vendors from my perspective, because I'm looking more from the RIC and xApp and RIC point of view, to me the biggest benefit that I see from an R&D perspective is we really get to see how different RICs can work, or how different xApps and RApps, I should say, can be implemented on top of the different RICs, and how the entire workflow of the apps that create one use case can work together in concert to create the performance increases or optimization of the network as we would want to. Because it's not easy for the vendors on both sides, the RICs and the xApps and RApps, to create this environment, to interoperate what they've created. Also having in mind that some of the standardization in terms of the architecture of the RICs and the features of the RICs is still ongoing, right? So then it's not always clear what is, what's the within the domain of responsibility of the RIC versus domain of responsibility of the xApp or RApp. And especially when we're talking about the, for example, the benefits of using artificial intelligence, machine learning, right, AI, ML, then it becomes much more difficult for different vendors on the RIC to interoperate with xApp and RApp vendors, because not all RIC vendors have the same SDK, for example, to allow the app vendors to develop their contribution on top of their RICs, and vice versa, right? So it's really, I would say, it's very challenging, and I understand the struggles that both RIC vendors and xApp and RApp vendors are going through, and I think that's why pushing for more of these interoperability tests, right? Pushing the community, both industry and I would say academia has been very significant as well to work together to create more environments, neutral environments in which these interoperability tests can be conducted and performance tests can be conducted. I think we're seeing more and more of that happen, and that will result in the faster development of the technology itself, right? Because until we do it and until we see it done, we're not going to know how we are performing.
Yeah, and I think that you actually are raising an important issue, because we often think of interoperability as something that operators need to make sure is there, right? So like, and clearly that's something you need to do, but in order to get there, there is a lot of work that vendors have to do, and it's not just sometimes there is sort of the assumption that if you're not interoperable, it's your problem as a vendor, but really it's very hard, because you in order to be interoperable with others, it's a sort of like a back and forth type of effort. So there is a lot going on, and in fact there's like a three, so the different vendors have to work with each other, then the operators need to make sure that it's interoperating with their network, and so it's really truly an ecosystem wide thing. Now, we have a lot of questions from the audience. So let me ask first one, there is one that is still close to what we're talking about, and that's on SMO. Is there a risk that SMO and RIC functions might conflict with each other?
That's a great question. So I would say and it's a very interesting one because there is no definitive answer in terms of how the architecture for SMO and non-real-time RIC will look like. There's different flavors of it, definitely, and there's a way of thinking that these two components should be separate, right? But then there is thinking as well that the non-real-time RIC almost resides within the SMO. I think moving forward, we'll be seeing more and more, and this comes back to, I think, different use cases and maybe specific objectives that an operator would have, for production network, for, large-scale deployments, or for private networks, private 5G. I think there will be architectural differences that we will see happen as we more and more implement these use cases and see what actually resonates better, what brings what is actually more maybe from a practical point of view better. And so for sure there will be some more development, some more work that needs to be done to distinguish the functionalities between the SMO and non-real-time RIC, especially if those are decoupled, right? Like how you collect data through the different interfaces in ORAN that connect the SMO and non-RT RIC, and this is 01, 02. Where does the data reside, and who does the full management, like not just the collection of the data that comes in, but also the pre-processing of that data, the management of that data, the creation of, for example, the feature sets that are going to be used in different machine learning models. And when we get to machine learning, then the question becomes, in an environment in which the SMO and the non-real-time RIC are separate, how are we harvesting the power of both of them to create the machine learning pipelines? So it becomes, I think, that we need to have more conversations in terms of functionality, from a point of view of not just practical, but also trying to find the best optimal solution for different scenarios. How does that architecture look like? Whether the non-real-time RIC is within the SMO or decoupled from it, and then how does that influence the entire workflows in the ORAN ecosystem?
Okay, one thing I want to point out, Michael, I see that you have your raised hand. If you have a question, please type it in either in the Q&A or in the chat, whatever works better for you. Now, a follow-up on this question, do you expect, I mean, and clearly it's kind of early days now, I mean, there is no clear answer to this, but do you expect in general that operators would select a different vendor for real-time, non-real-time, near real-time, and SMO? Or would they say, well, okay, let's just keep it simple, let's just go with one vendor for the three of them?
I would give the optimal answer, and then I'll give my speculation or my thought, my opinion on it. So I think if we look into the philosophy behind ORAN, right, the driving forces of openness, disaggregation, interoperability, softwarization, then we for sure would want to be able to, if we see the benefit of deploying different, using different different vendors from for the near real-time, non-real-time, and SMO, we have that possibility, right? That would mean that we've come to a point where the standards are so well developed, interoperability is on such a high level that we're able to to cherry pick, to choose whichever component we want, just based on the performance, based on practicality in terms of large scale deployments, right? So I would say that that should be, I think, how we look into the future, what we have in mind when we're working on these standards, right? Full interoperability and ability to choose based on some metrics that we have in mind, but that shouldn't go back to, you know, restraining based on interoperability. So that's, I think, the optimal way to do things. I would say that my thinking, at least in the next couple of years, is that we might not get there, and that we would still be a little bit more restrained into how we pick different vendors. I think as the technology and the standardization evolves, but also the implementation of the standardization evolves, and there is to some extent incentive for vendors to create exactly based on the standards their products, then we will you know, get to the optimal, but we're still yet to get there. And I think we always need to have in mind, again, I'm saying, I know I repeat myself, but I try to remind myself as well that ORAN is a fairly new technology. It's a paradigm shift in the way we think, and that the standards are just now developing, right? So we need to kind of remind ourselves of that and push for more and more to be done, but also be a little bit patient when it comes to having the best of everything.
Absolutely, and as you say, it's being a paradigm shift. I think we don't even understand entirely, or we don't appreciate entirely the depth of the change. And in fact, well, it's not that we don't understand it, we don't know it yet because we're in the process of finding it out. So it's not just step 1, 2, 3, and then we're done. It's step 1, 2, 3, and that's going to be step number 4, and maybe we don't know yet, and that's perfectly fine. But, you know, as I say, we need to be patient, which is why, you know, I started thinking more about Open RAN without the capital O, because it's really like a long-term process. And so, and if you try to speed it up too much, then you might actually, we might actually force ourselves to make choices that are not necessarily the right ones. So we really need to have a broader view, accepting the fact that there's still things we don't know, and that's okay. You know, that's okay. Why don't we go to some of the questions from Aaron? Aaron has 4 very good questions. So let's go to the first one. And that's what's the current status of near-time RIC and near-time RIC? And can I say that near-time RIC is not mature yet? So maybe you can talk about the sort of the timeline and for the two of them, and why is it different?
Sure. So I would say, good question, Aaron. I would say that it depends on I think how we define maturity, right? I would say there have been lab trials, field trials, even, you know, larger scale deployments of ORAN in general across you know, the world, especially in Asia and parts of Europe. It might not have been a large scale as we would like to see, but it's still some footprint of the network. But I would say in terms of, for example, standardization, we're still undergoing the process of, for example, defining all the service models, let's say, in the E2 interface between the RAN nodes and the RT RIC. And then once those service models are fully standardized, then the industry, the vendors need to fully implement and integrate those service models and capabilities, right? So I would say, if we're talking from a point of view of the majority of the standardization being done and the majority of the implementation by vendors being done and tested, then I would say we're still not there yet. and there's still a lot that needs to be done.
Okay, now the next question is more about Bell Canada. So you decide how much you can share with us, or really. So the question is, how do you expect introducing RIC to your network, as both Ericsson and Nokia, the legacy vendors, also provide SMO functions, or do you focus on other small vendors' RIC, and what's the drive behind? Would it be more beneficial using legacy RAN vendors as for the RIC? Is that going to mitigate the integration effort? So it's a huge question of how do you see different vendors basically fitting into your into your RIC and SMO functions.
Yeah. Thank you, Aaron. Again, insightful question. I can see that you know a little bit about Bell Canada and the footprint. I would say that, you know, there's definitely the I guess any brownfield network goes through this thinking process of what to do, especially when you know, we already have 5G, as you mentioned, Ericsson and Nokia in our network. I think the strategy is to first you know, start small and learn about ORAN more and more, right? And I think once we get to a level of understanding about how the technology performs and, you know, how the different stacks perform, and you know, looking to get to a more mature technology where we're able to, for example, use different xApps and RApps in different use cases to optimize the network. I think once we get to that level of certainty that you know, the performance is where we want it to be, and that we have all these different applications, future-looking applications, tested and I would say tested in a more large-scale scenarios. I think that's when we will be drawing decisions what needs to happen. And until then, I think from the perspective of my own job, which is more on the technology discovery and R&D side of things, we're trying to understand more how ORAN performs, and we're trying to push efforts to, or I should say, I'm trying to push efforts to kind of get to a point where we can massively test all these different applications and RICs and learn more. Once we learn more, then it's the job of our teams to figure out how we would like to proceed with you know, more strategic thinking in terms of footprint.
Absolutely, and I guess that's again, it's still early days, so it might be hard to really predict exactly what's going on. Next, the third question from Aaron is for xApp and RApps, the third party or open source community might not have sufficient knowledge experience when with implementing 3GPP for RAN features. Is that a concern for you? And I guess that okay, so I'm gonna add another sort of question here. Is the xApp and the RApps going to be basically something that the existing vendors already do in a different context? So it's basically a functionality that, because this is not entirely new functionality, right? So they would just basically build, well, repurpose, so to say, the functions that they have within an xApp or an RApp, which is perfectly, I mean, which at some point we're going to need to do that, so that we have the same functionality in using a different basically platform. Does it make sense? So is that something that you're going to see as well? So we're going to have new vendors, new xApps and RApps, and there is a question: do they have all this the knowledge? And on the other hand, are we going to see existing legacy or, you know, established vendors basically repurposing what they have as an xApp or RApp?
That's a very good question. I like it. So I would say the promise, going back to the promise of WARN and RICs, right? We should be able to have any vendor, whether it be like a specialized xApp vendor, could be a vendor that only specializes in a particular xApp, but does it so well that brings so much reduction of CapEx, OpEx, or it brings the innovation, the differentiation that we need to be able to even create new services, right? So it could be a vendor that specializes in a particular xApp or RApp. It could be, traditional RAN vendors migrating towards, or not migrating, but offering this type of xApps and RApps as well, and doing it very well. It could be the case that we also have and this is an interesting one. We also have the capability now to turn academic research coming from research labs in the academic and the university into xApps and RApps that actually provide a lot of differentiation, a lot of novelty in the way we tackle these problems. A lot of, for example, novelty in terms of using machine learning in a certain way that provides much better performance. So I think it could be, and this is the goal, to have such an open system to bring this sort of innovation and differentiation that brings forward the optimization of networks, especially moving towards the next generations of wireless technology. So that's my dream would be that we do have this openness and we do have everything that all these vendors, big or small, have to be able to deploy those applications on the RICs.
Absolutely. Let's take a break a little from Aaron's questions. And there was another question that I'm going to repurpose in a little bit, since you just mentioned AI and machine learning. And so the question was like, how is that going to, is that going to be a challenge or help? How important is it to have AI and machine learning into this whole process in developing and pushing, in developing and getting RIC to maturity?
So I think looking, forward, and I think trying to be much, not just bleeding edge, but trying to almost like think about how the future looks like. I think we're more and more aware about the power of AI and ML in all the different areas of life, including networks. And I think we need to be well prepared in terms of creating the right architectures for the RICs to be able to harness the power of different ML models into the xApps and RApps. I think we're learning over time that data-driven decision making can offer a lot of possibilities, and it's on us to find the best way to create these applications based on ML and then test them to see whether they perform better than what's been traditionally done in terms of optimizations. But I would say that preliminary research using different machine learning approaches such as reinforcement learning, for example, in the RAN, has been showing very, very promising results, and it would be great to have the foundation for the RICs, the development of the standards, development of the architecture, to be able to, in a more easy way, harness the power of ML/AI and have like a shorter development cycles to create these applications and test them.
Now we're going to get to another question from Aaron that I'm going to supplement as well. And I wanted to get it because I know you're working on network slicing as well. And so his question is, what's the most important application Bell focuses on in RIC? And maybe here you can also tell us that, but also maybe you can comment on how network slicing and RIC, is there any overlap, or to different projects here.
Sure. So maybe I'll start with the second question. I would say this is a good point, because when we start looking into network slicing and slice assurance, especially, we look at it from a point of view of, let's take the foundational blocks of this new technology and see how everything interrelates, right? So you have the situation in which network slicing by default is the ability to create slices end-to-end, so RAN transport core, and be able to programmatically change the behavior of those slices, the resources that you allocate, the configuration of those slices based on current demands or anticipated demands. So there's a lot of, to be able to achieve that, you are relying, if you want to make it in a dynamic way, you're relying on Softwarization, you're relying on openness, you're relying on many of the same foundational blocks that ORAN has itself as well. And then if we try to look at it from a point of view of, let's say that the goal, especially, I sometimes tend to maybe dream a little bit, but especially in technology discovery, right? Let's say that our North Star is the ability to create network slices that are able to very efficiently address the needs for, as I was mentioning before, vehicle to everything, or Industry 5.0, or remote surgery has been a driver for next generation as well. So let's say that the North Star is we want to be able to have such good control over our network. First, visibility, right? We need to know how the network performs, but then we have all the mechanisms to programmatically change the behavior of the network based on the current situation. So we are able to anticipate the needs for those very, very demanding applications or service types, right? Here's where ORAN provides the toolkit, the mechanisms to do that, because with the promise of the near RT-RIC and the sub-second control loops, and especially when we talk about real time and the control loops that are going in millisecond ranges, right? Then we do have in the RAN the right mechanisms to control, manage, and orchestrate the network in such a way to be able to achieve those requirements for those types of applications. So these technologies work. The foundational blocks are almost identical, and then they do need to work in concert, right? It's not one or the other. It's how do we harness the power of all these technologies, ORAN and end-to-end network slicing, to be able to create those types of services. So that would be the answer to that question. And in terms of, I think the other question was like use cases that we're interested in, we're looking at. I think we're looking at use cases that really provide, and I would kind of categorize them into use cases that provide differentiation, right? New revenue opportunities, but differentiation in terms of what can we do better, right? How do we use ORAN and the use cases to create ways to innovate, to differentiate ourselves and offer better service. And then the second one is how do we actually make it efficient in terms of cost, right? How do we make our services more efficient, but also how do we make ORAN more efficient? So I would say the ones that I'm very interested in are related more to traffic steering. So how do we have a better, more intelligent, more knowledgeable, data-driven traffic steering? And then RAN slice assurance. That's another one that's very interesting. And it works well into combining all of these network domains together. Energy efficiency, spectrum management are other very, very important use cases from an operator perspective, because those are almost like the foundational blocks. How do we make the network more efficient, and how do we make sure that we are harnessing the power of data-driven decision making of all of these new technologies coming in to make sure that we've optimized the way we use all of our resources, right, in the RAN, from physical resource blocks to computing power of the CUDU and everything in between.
Yeah, and I guess from what I hear from you is that it's not so much like a few separate use cases, but really to put RIC within the whole context and multiple use cases, multiple dimensions. So it's really like getting it into the the whole network. Unfortunately, we're done with time. We have a lot other questions. I have questions. The audience has questions, but maybe we'll get to them at some other time. But thank you so much for sharing so much knowledge. I think you clarified, at least for me, a lot of the issues around RIC, and I hope for the audience too. And those of you in the audience, thanks for participating and asking so many great questions. So Simona, thank you so much for being with us today.
Thank you for the invitation, Monica, and I want to thank all the participants as well. This was we had so many great questions. I'm very happy.
Very, very good and tough questions. And Kendra, back to you.
Okay, great. Thank you, Monica. That will conclude our webinar for today. A recorded version will become available at senzafili.com, so you can access it there. And thanks again to our speakers and our audience members. We have 2 upcoming sparring partners. The next one will be December 6th. And following that one, we'll have one on December 13th. And registration for both of those will be available at senzafili.com. Thanks again, and we look forward to seeing you at future events.